So you found the skeleton. How would you tell people that was you personally? How would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there, YouTube, the Dapper Dinosaur here, back with more Creationism and the Big Bang, and I know it's been a while, but as you may or may not have known, I was pretty sick for a ridiculous amount of time. And so it's only just now that I'm actually getting around to doing some audio recording. And I've had this thing scripted for almost 3 weeks. So there you go. We're going to keep going with this same lecture. And without further ado, here it is.
The evolutionists love to say that, but whenever I hear that, I know that that person either doesn't really understand science and the nature of this origins debate, or he's trying to confuse us.
Or, and just hear me out here, maybe he realizes that methodological naturalism is the only way to make consistent progress in all possible areas in science, and doesn't appreciate backwards Luddites like you trying to stifle the advancement of science.
Because to understand this origins debate, we need to understand that there are two broad categories of science. I like to call them operation science and origin science.
If you saw the Ken Ham Bill Nye debate, then you'll recognize this distinction as one of Ken Ham's main points. According to Ham, and I suppose his mooks, operational science is about the present and origin science is about the past. Except that that's an artificial distinction. The only reason to assume it is to assume that the past operated fundamentally differently to how the present operates. But that's incoherent, as the present continually changes into the past, and we don't see the present behaving in some chaotic, unpredictable manner from moment to moment.
Operation science is what we normally think of when we think of science. It's also called experimental science or observational science.
Well, since the Big Bang Theory is based on experiment and observation, I suppose it's part of the operational science, even though it's about the origin of the current state of the universe. Good to know.
And it's the science that produces technology, finds cures for disease. It's the science that put a cell phone in everybody's pocket.
I'll grant you that the Big Bang hasn't done a lot to get people new gadgets or cure their ailments, but that's not the criteria for something being true or scientific. Something could be completely useless and totally scientific. Utility and scientific merit are separate things.
And so most of biology, chemistry, physics, meteorology, what they do on the evening news, weather report, engineering, medical research, those are all forms of operation, experimental, observational science. We're studying things in the present.
We're not studying things in the present, though, are we? We're studying how things worked in the past. Because even if you're watching an ongoing experiment, it takes time for the information you're gathering to get to you, and even more time for your brain to process it, and more time still for you to write it down. Because of how the universe works, all observations are necessarily of past events. We don't have access to the present, and the fact that we seem to is fundamentally an illusion. So how far back in the past does it have to go before it doesn't count as observational science? Does the forensics used to solve murders count?
To see how they operate, how they function, whether it's cancer cells or weather patterns, and we're trying to figure out how to predict things, how to manipulate things, how to produce new technology.
You don't see how the ability to predict things relies on the assumption that the laws of the universe operated in the past as they do today, and that they will continue to do so? If that's the assumption of science, which it is, then you can extrapolate into the past just as well as you can into the future.
But that kind of science won't answer the question, how did Saturn come into existence?
Why not? I mean, if we assume the general temporal invariance of how the universe operates, then we should be able to find a model that fits how the universe operates that can explain the formation of Saturn, assuming it formed naturally. Then, test it by looking to see if the predictions of that model fit both new information about Saturn, as well as fit what we might see in other star systems, which conveniently we can now learn about. And of course, if Saturn got there by magic, and couldn't form naturally, then no proposed model of natural formation will actually fit the facts of Saturn as they are observed now, and observations of exoplanets will not correspond to predictions of that model.
Because you can't recreate Saturn in the laboratory. It's there, and you want to know what happened in the unobserved past to produce that planet, to produce those rings.
Right, but you can look for extrasolar systems where planets like Saturn are forming, You can look for confirmed predictions in modern Saturn and its rings based on your model of Saturn's formation. And if your predictions are wrong, then so is your model. Odd as it might sound, we can make predictions about the past and confirm them in the present.
That's a historical question.
You might not know this, but I actually have a degree in history. And trust me, the formation of Saturn is not a historical question. History deals with the records of humans, particularly their written records. So unless there's a hidden record of humans watching the formation of Saturn, then it's not a historical question. And even if your interpretation of Genesis were true, it's still not a historical record of the formation of Saturn specifically, so it still wouldn't be a historical question.
And so for historical questions, we need what I call origin science. And that's also sometimes called historical science. And historical geology, trying to figure out the history of the Earth. Paleontology, studying fossils. Paleoanthropology, studying human fossils. Paleoclimatology, trying to figure out what was the climate like 1 million years ago. Archaeology, cosmology, and forensic science. That's what police detectives do, trying to solve the question, why is that dead body in the living room?
You had historical geology, paleontology, paleoanthropology, paleoclimatology, archaeology, cosmology, and forensic science up there. I guess not actual history, though, since it's none of those things. History gets no love. So none of these sciences are based on observations in the present and predictions about future data, huh? That'd be news to everyone working in those fields. In fact, I've gone on at length before about predictions made and confirmed for hundreds of years in paleontology. Seems like you're just picking on these sciences because they are the ones most at odds with your laughably absurd notions about the history of the universe. Also, I love how you're lumping forensics in there, because now that means you're invalidating basically the whole basis for evidence in criminal cases. I guess let's just let all the murderers go.
That's a historical question. These are forms of historical science. And I can illustrate the difference between the two if I think about a car. A car mechanic is an operation scientist. He knows how the car operates. He knows how the pistons go up and down. He knows how the air conditioner works. And if it doesn't work, he knows how to fix it.
Except he's not a scientist, he's a technician. Scientists attempt to expand scientific knowledge. Engineers use well-established scientific principles to design technology and processes. Technicians are experts in the operation and maintenance of various forms of technology. So science flows from the scientist who discovers it, to the engineers who use it to design things, to the technicians who use the designs to actually accomplish things in the real world. These titles are not interchangeable. An auto mechanic isn't a scientist, but that doesn't mean he isn't smart. It does mean that he's ill-suited to your analogy.
But just because he knows how the car operates doesn't mean he knows anything about how the car came into existence.
But the thing is, if the creation of cars were a mystery to him, he could learn about them and make hypotheses that he could test. For example, he could test the material properties of the substances the cars are made of. He could look for machine marks on parts. He could look at how similar items are created, etc. And from this, he could make a hypothesis about the manufacture of cars, and make predictions about what he might expect to find in places on cars he hasn't examined to see if this is correct. And chances are that if he's rigorous enough, he'll get some pretty good idea of how cars, in fact, are created. And while he might not ever get it 100% right, he'll certainly do better than if he just stuck to whatever made-up answer struck his fancy first.
The way the pistons operate doesn't tell you how the pistons came into existence.
No, but the structure of physical features and composition of the pistons can give you clues to it.
That's a question of origins. And so the car manufacturer is the origin scientist. He knows how the car operates, but he knows how every part of that car came into existence.
Again, this is a bad analogy, because the manufacturers are a group primarily made of engineers and technicians. There are some scientists working on things like new ways to improve fuel efficiency or safety, but still, the vast majority of the process of car design and manufacture is not science, it's engineering and technical work.
The question of origins is a different question than the question of operation. We know how things operate, some things about what some things operate in our universe. We know how some things go around other things, some in very elliptical orbits, some in pretty close to circular orbits, and things rotate on their axis. So we know things about how they operate, but the question is, what do people know about origins?
In some cases, a lot, And of course, the story of origins can't contradict how things operate in the present, so that eliminates at least some otherwise possible accounts of origin. But the fact is that, given the current understanding of science, we can and do look at objects and come up with testable, falsifiable, and sometimes confirmed hypotheses about how these things came to be.
So the question of operation is one thing, the question of origins is a different question.
A different but related question. Since how things operate in terms of physics gives us information about how things operated in the past and will operate in the future. Because nature is predictable, at least in principle.
And we need to understand that all of the scientists, whether they're creationists or evolutionists, they have the same things to study. They have the same stars, the same galaxies, the same planets, the same stardust, the same starlight.
Yup, and where creationists actually stick to the scientific method, they've been known to do good work. In fact, Henry Morris, one of the founders of modern creationism, did good work in hydrodynamics. Of course, outside of that field, he went a bit crazy, as he was laughably wrong and not even internally consistent, like most young Earth creationists.
And if they start with naturalistic assumptions, they come up with a Big Bang and billions of years for the formation, the origin of these things.
What he means is that if they follow the scientific method in the only way that's actually practical and that gives results in every field, they'll come up with things like the Big Bang.
Those who start with biblical assumptions look at the very same objects and they see all kinds of evidence confirming that the universe is designed and young.
And what he means here is that if you disregard the scientific method and just force all data to fit a predetermined narrative, while disregarding data you can't force hard enough, you can come to any conclusion you want. I guess that's not technically incorrect. You can do that. Just don't expect to be taken seriously or for your ideas to ever be validated or make successful predictions.
So we want to look at this, and I want to begin by looking at what the evolutionists know about origins, and then we'll look at what the Bible says about origins.
I'm not sure if that was just a slip of the tongue on his part, but he's right. Scientists, that is, the people he calls evolutionists, know things about the origin of life, the universe, and everything. In some cases, less than they'd like to, but still they know some things. All he has is an interpretation of the Bible that he's not allowed to test, so he can't know anything.
And to keep this simple, we're going to start with our nearest neighbor, the moon, and go farther and farther out into space. So let's consider the origin of the moon. And the evolutionists have proposed several theories for the origin of the moon. They have technical scientific names. I've given them simple names to help me remember and help you.
Now we actually get to some astronomy. And, well, there isn't a theory of moon formation. Not even one. Never mind 3. But the most likely hypothesis at this point is that the moon formed from ejecta resulting from a collision between a newly formed Earth and a body about the size of Mars, which has been dubbed Theia after a titan from Greek mythology.
One is the sister theory. The idea here is that when the Earth was a hot metal ball spinning on its axis, No, that's not the one. I just got confused. No, the sister theory is that as there were rings around the sun, 2 centers of gravity developed in what is now the orbit of the Earth. And the material got pulled in around those 2 centers of gravity. One of those centers of gravity eventually became the Earth. The other became the moon. Nobody ever saw that happen.
Nope, no one did. And we have good reason to think that that's not how the moon got here. For example, it has trouble accounting for the relatively large amount of angular momentum in the Earth-Moon system, and it doesn't explain why the iron core of the moon is so small. So, scientists made predictions based on a model of the past, and present observations have largely disconfirmed the hypothesis. It's almost like they're doing observational science about the past. Also, for the record, this is called the accretion hypothesis, a name that actually describes what's being talked about.
Nobody ever did a scientific experiment in the lab to show that that happened.
First, a laboratory isn't required for science to be done. Meteorology and astronomy come to mind as 2 major sciences that you've already accepted as science that generally don't do lab experiments due to the scale of the structures being observed. That being said, I can guarantee you that people built simple physics simulations and ran them to see if the hypothesis was viable. That's an experiment.
People were speculating about the unobserved past to explain the moon that we see in the present. But there were lots of theoretical problems with that, as well as no observational support, so that theory has been discarded.
If you know it's been discarded, then why are you bringing it up? Also, the very fact that the hypothesis has been largely disconfirmed is evidence that scientists aren't just creating a narrative to fit their beliefs. If they were, they wouldn't have discarded the hypothesis when it was disconfirmed. I sense some projection, since it is in fact the creationists who think that discarding their disconfirmed hypothesis is a bad thing.
Another one is the wife theory.
This is actually the capture hypothesis. Again, a name that's useful and descriptive.
Now, this doesn't actually explain the origin of the moon, but explains how the moon became the satellite of the Earth. The idea is that the moon was floating through the solar system, it came close to the Earth, and the Earth looked up at the moon and said, "Hey, I really like that lady." And so the gravitational attraction of the Earth pulled the moon into orbit.
And the biggest problem with this hypothesis is that it's just not really possible. Gravitational capture can be a thing, but it's essentially impossible without at least 3 bodies. With only 2 bodies, gravitational interactions will generally result in either a collision or a trajectory change for both bodies as they exchange angular momentum. In fact, let's see an example using Kerbal Space Program, which is a game that uses a gravity simulation to simulate spaceflight to demonstrate why capture is unlikely. So I put this sort of cheaty spaceship on a flyby course of Dres to show you what happens when you have a close encounter with a gravitational field when there's only one real thing affecting the gravity. So all Dres is just a rock in space. So as we fly by it, we're going to start to curve towards it, but then we're going to fly away again. So here we are on very close approach. We actually get pretty close to the ground, but there's no air, so it's safe. And then we just fly away. That's one of the reasons why the capture hypothesis for the moon doesn't really work, because if something came really close to the Earth like that, why would it enter orbit? It wouldn't. It would just fly away. But next we're going to actually see how you can capture. So I sent the same ship with Valentina Kerman, our brave Kerbonaut, on her way to Joule. Now Joule is a gas giant, which is sort of analogous to Jupiter. So you can see here that she's coming in, and she's going to encounter Tylo, which is a moon of Joule, and that will change her orbit around Joule such that it becomes a stable orbit. So here she is, actually getting closer to Joule. She's falling towards Joule in the same spaceship. And you can start to see the moons of Joule going around. This is on some time acceleration because Kerbal Space Program would take far too long to play unless you could speed up time. So right now we're going at like times 100 speed or something. Also of note is the planets in the Kerbal Space Program game are about 10% of the size of normal planets with that gravity. And that's just for gameplay reasons. So now we're starting to see Tylo approaching us closer and closer because our fall into Joule's sphere of influence is going to intersect with a close approach to Tylo. So the interesting thing is we don't get to orbit around Tylo this way. So just like with Dres, we're only going to have a close approach to Tylo. And you can see that coming up right here. So just like before, we come in, we're going to get extremely close, because the closer you get, the more extreme the change is going to be in your resulting trajectory. Now you can see the ground of Tylo. And there's Joule and Lathe in the background. And so now we've flown past our lowest point, and we're now exiting the area around Tylo. And we're going to switch back to the map in a little bit and see that we're actually in orbit of Joule. Now this orbit may or may not be terribly stable. It probably isn't, because it probably will result in me encountering at least Tylo again and possibly other moons. But if that happens, I may end up in a different orbit, and eventually the orbits may either settle out so that I'm in an orbit that tends not to encounter other bodies, or it might just eject me from the whole system. So now you can see I am successfully in orbit. But the reason Valentina volunteered to be in this ridiculous spaceship that doesn't even have any fuel on it is because I promised that she could retire to a beach. So I'm sending her to Lathe. So this is just a fun little bonus. So she's landing near the beach. I say near the beach, but it took me like an hour to run from where she landed to the beach. But you guys don't have to see that. And touchdown! Well, the rocket didn't make it, but there was no fuel on there anyway. The whole thing was just cheating. And here's the run to the beach. Finally got to the beach. Time to put out a flag to commemorate this by. So I want to give special thanks to the developers of Kerbal Space Program, Squad, for making this game, which has allowed me to demonstrate some orbital mechanics, as well as I'd like to thank Valentina Kerman, our brave Kerbanaut, who is home at last by the beach. And she always thought that she would retire to a beach, but just not one on Lathe, which is a moon of Jool. And here's the view from the beach of the planet. There you go.
Now, nobody ever saw that happen. Nobody ever did a scientific experiment to show that that happened. And there are huge theoretical problems, one of which is if the moon came in towards the Earth like that, it wouldn't immediately go into orbit. It would boomerang off in another direction. So that theory has been discarded. And then there's the daughter theory. And there are actually a couple variations on this. One is that when the Earth was a hot metal ball, it was spinning on its axis, it developed a little bit of a bulge on one side, and as it was spinning, that bulge stretched, and pretty soon it broke loose, cooled, and that became the moon.
This is called the fission hypothesis, and it is entirely inconsistent with the geology of the moon.
Another is that the Earth was bombarded with meteorites and asteroids over a long period of time, and chunks of material got blasted off the Earth out into space. It eventually all got into what is now the orbit of the moon and all got together. Nobody ever saw any of that happen. Nobody ever did a scientific experiment to show that that happened.
As far as I can tell, this hypothesis has never been seriously proposed, so I don't know what he's talking about. But of course, experiments could indeed be done. But I think that's where we're going to leave it for now. It's already been a pretty long video. Please remember to like it and share it. I'm the Dapper Dinosaur.
Thanks for watching, but before you go, I'd like to take a minute to thank my patrons, especially my $20 patrons. Bent Hovind, Ian Chen, Bob Knob, The Evil Scotsman, Henry Hutanen, Chris Love, and Res Instance. My team over at Patreon are helping me make these videos, and I have tiers starting as low as $1 and going all the way up to $100. So if you'd like to help out the Dapper Dino channel and help make these videos better and possibly even more frequent, then why don't you head over there and check it out. If a recurring donation isn't right for you, but you'd still like to help out, I have a link to my Amazon wishlist in the description. I'm the Dapper Dinosaur.
So you found the skeleton. How would you tell people that this happens? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on this.